So we're in section 1.7 and we're going to talk about transformations with coordinates. So with our opener, we reviewed a little bit what we're talking about, and this is just a recap what we did yesterday and what we talked about just now with our opener. We're talking about rigid transformations, and we have three rigid transformations: translation, rotation, and reflection. And our rigid transformations were important because they don't change the size or shape of an object. So we use rigid transformations to come up with a stronger definition of what we mean when things are congruent. If we can move an object through a series of rigid transformations and it's exactly the same as the other objects, that's how we decide that they're congruent. All right, let's have a quick reminder on how points and coordinates work, just so we remember. So if this is an x and a y axis, so this is y and this is x, and if we have a point here, so I'm going to call this point 3, 1, this is point 3, 5. So I'm just graphing on this set of axes. So when I go to the right, I'm going the positive x direction, and when I go up, I'm going the positive y direction. To the left is negative x, and down is negative y. So 0.35 tells me I'm going over 3 units in the x direction and up 5 units in the y direction. When I write my coordinates, I write x and y. X and y, x is always first. These are in alphabetical order, x, y. And if it helps you remember, I had a student once tell me he thought of you have to walk before you can fly. So you have to move left and right before you can go up and down. So just a quick reminder on what we mean when we're talking about our x coordinate, our y coordinate, and how our coordinate axes work. So what we like to do a lot in math is we have this idea of what a transformation is: translation, rotation, reflection, and we want to put numbers to it. We want to use numbers to describe what we're doing. So that's really what we're doing today is how do we put numbers to these transformations. So let's start by talking about a translation. So the first ones we're going to talk about are translations. So I'm going to draw a set of axes here. And we'll label our x and our y. And we'll put a point on our, I'm going to go over 3 and up 2. So this is point 32. And the first one I'm going to talk about is a horizontal translation. So for a horizontal translation, I want to move over here, so let's move over horizontally. So I'm going to go over 1, 2, 3, 4, and I'll draw this in blue. It was kind of like this. We'll get to that one in just a minute. Oh, this isn't 4, 2. I'm over here at 1, 2, 3, 4, 5, 6, 7, 2. So from the point 32 to the point 72, what changed? I moved right 4. And what about in my coordinates? Made which one go up? The x number got bigger by how much? I added 4 to my x coordinate. Now what if I go over here, and this is at point -1, 2. What changed moving to the left? My x coordinate changed. And how did it change? Negative. By how much? -4. So to move to the right, I added 4. To move to the left, I subtracted 4. So for a horizontal translation, what I do is add or subtract on the x coordinate. And if I write this, we like to use symbols in math. So the way I would write this, I'm going to call my translation H. That's just the name of the translation. So H of x, y. That's just saying I'm doing a translation, a transformation to x and y. I'm going to say x plus h, comma, y. And I'm adding or subtracting h units from the x coordinate. And this is a translation, h units left or right. So to move left or right, I just add or subtract a number from the x coordinate. That's all I have to do to move up or left or right. Now let's look at an up and down transformation. So go over here, draw another set of axes, and we'll get that lined up a little better. Did you have a question? Okay. So here's another set of axes. And we'll start with our point here. Let's start it at 3, 2. Same point. And now I'm going to go down here. -2. Sorry, this isn't -2, 2. This is 3, -2. So what changed here? Between the black, the coordinate in black and the coordinate in red. What changed? We changed the y by -4. And if I go up here, and this is at 3, 6. What changed between the black coordinate and the red coordinate? The y changed by 4. So to go up or down, and we call that a vertical translation, we add or subtract on the y coordinate. And we're going to call this transformation V. We just give it a name. That's the name of our transformation. Is x. X doesn't change. And we add V to the y coordinate, add or subtract. And this is a translation, V units, up or down. So to move up or down, we just add or subtract on the y coordinate. If we add, we're moving up. If we subtract, we're moving down. Left or right, add or subtract on the x. If we're moving right, we add a number. If we're moving left, we subtract a number. So this is how we put numbers to our translations. Just adding or subtracting on the x coordinate or the y coordinate. And we can do a combination of them. We could go left 5 and down 2, and that would just be subtracting 5 from the x and subtracting 2 from the y. So we can combine our translations also. And we'll do a couple of examples in just a little bit. So this makes sense to everyone. So when we're doing our translations, we're just adding or subtracting from the x or the y coordinate. All right, so there's one of our rigid transformations. Let's look at another one. Let's look at a reflection. And I'll draw two sets of axes here. Oops. So there are my axes, x and y. And we're going to put a point. We'll use our same point over 1, 2, 3, up 1, 2. And we're going to, for our first one, let's reflect across the y. So we're going to reflect over the y-axis. So to reflect this point, I move straight towards the y-axis, and remember that a reflection the segment between our points makes a 90-degree angle with the mirror line, and it gets cut in half by the mirror line. So I'm going to move over 1, 2, 3, and then 1, 2, 3 more. And I'll label this point. We're at -3, 2. So the y-axis is our mirror line, and I reflected this point over the y-axis. So what changed here? The x, and what happened to it? It changed. Went down by -6. So let's look at another reflection. So this is at 2, -1. So let's reflect that point. And this point is -2, -1. So what is happening to the x coordinates here? They're turning negative. Perfect. So to reflect over the y-axis, we change the sign on the x coordinate. And if I call my transformation m, we'll say m of x and y. This is minus x, y. So we just change the sign to reflect over the y-axis. We change the sign on the x coordinate. Now let's reflect on the x-axis. Let's start with our nice point here, 3, 2. Now I'm going to reflect on the y-axis, so I'm going to go down here, and I'm at the point, sorry, the x-axis, yes. And I'm down here at the point 3, -2. So my mirror line is the x-axis. So what changed here? What happened to my coordinate here? The y coordinate, the y-axis, the number on our y that tells us our y coordinate changed to a negative. It changed sign. So to reflect over the x-axis, we change the sign on the y. And if I write my transformation, I'll just name it n. N is just the name of the transformation. X negative y. So I just change the sign on the y, and that reflects our point over the y-axis, or over the x-axis. So that we change the sign is kind of backwards. The axis that we reflect over, that coordinate doesn't change, it's the opposite coordinate that changes. So this is how we put numbers to a reflection. In order to reflect over the x-axis, we change the sign on the y-coordinate. Reflect over the y-axis, we change the sign on the x-coordinate. So questions on that one? All right, the last one we need to talk about is a rotation. And this was the one that was in our in the math box. We wanted to reflect over the y-axis. All right, a rotation. Rotation it's a little more complicated to figure out what's going on with the coordinates. So I'm just going to tell you how it works. And we're going to look at one kind of rotation. If we rotate 180 degrees around the point 0, 0, and another name for 0, 0 is the origin. To rotate 180 degrees around 0, 0, around the origin, we change the sign on the x and the y. And we would say our transformation R, we'll just name our transformation R on the point xy is minus x minus y. So we just change the sign on the x and the y. Let's do some examples and then we can go. So we're going to change the sign on the x and the y. Thank you. And this rotates us 180 degrees around the point 0, 0. Questions? Okay, let's look at a couple of examples. So I'm going to call we want to describe these. We want to describe the transformation. So if I take my point x, y, and my transformation is x plus 3, y plus 2, we want to describe this. So what are we doing to this point? Well, let's look at the x coordinate first. What are we doing to the x coordinate? Adding 3, and what does that do to the point? If we add to the x, do we moves the x-axis, moves our point left or right? So if we're adding 3, which direction are we moving? Right. And by how much? Right 3. And the y-coordinate, what are we doing to the y? Up 2. Adding 2 moves us up 2. Right 3, up 2. So that would be our description. This is what this transformation does to our point. Moves it right 3 and up 2. so let's say our transformation is called G. G of xy is x minus 5, y plus 1. So what does this transformation do to our point? Left, left 5, and up 1. That would be our description, left 5, up 1. This moves it to the left. If adding and subtracting to the x moves this left to right, we subtract, so that tells us we've moved left. So we've gone left by 5. Adding or subtracting to the y coordinate tells us to go up or down. We've gone plus 1, so we've gone up 1. What's that? This isn't rotation. This is just describing this transformation. All we're doing is trying to describe what we're doing to our point. How about, this one's a little trickier, if our transformation, we'll call it m this time, is minus x, y. What does this one do? Well, the y doesn't change. Am I adding or subtracting anything from the x coordinate? Is there a number here? There's not a 1 there. If I put a 1 there, I'd have it like that. So what did I do to the x? I changed the sign. I made it negative. So when I change the sign on the x coordinate, what does that do to the point? Look at your notes. Reflect. Over which axis? They're switched when you reflect. So this is reflected over the y-axis. When I change the sign on the x coordinate, it means I reflect over the y-axis. And then what about in xy minus x minus y? What does that one do? Okay. So reflects over x and y. And how do we describe it when we change the sign on both? It's a rotation 180 degrees around 0, 0. And a reflection across the x and the y is the same, turns out to be the same as a rotation 180 degrees around 0, 0. So either of those are perfect. And some of your homework problems ask you to draw the transformation. So let's look at one of those. So let's put my axes here. And we have a triangle. So there's my triangle, and my transformation, we'll call it M, is x minus 3, y minus 2. So first off, what does this transformation tell me to do? What am I doing to the x? Left 3. And y, we're subtracting 2, so we go down 2. So now I'm just going to take each vertex, and I'm going to go left 3, 1, 2, 3, down 1, 2. Take this one, go left 1, 2, 3, down 1, 2. Take this vertex, left 1, 2, 3, down 1, 2. And there's my new triangle. I've taken it left 3 and down 2 to get to the new position. So if I want to draw a translation, this would be how I would draw it. All right, any questions on this? Okay. Let me pass your folders back.